Hello, everyone. It's nice to meet you. I'm going to present my screen. So the subject I'm going to present is why mobile networks are the problem, but also the solution for IoT security concerns. I'm going to start with our mutual goal, which I assure you we all have. I'm going to map some cellular IoT security concerns and ask, can mobile networks save the day? And share why we at FirstPoint take a mobile network-based approach to security. We'll also have some time for Q&A. So like Annie said, my name is Noah, and I'm the Marketing and Business Development Director at FirstPoint. I've been with the company for 4 years now. Adam Weinberg, CTO and co-founder of FirstPoint, will join us for the Q&A session at the end. This is us here dressing up virtually for the event. Maybe you've dressed up at home, or maybe you're in your pajamas, and we welcome you gladly anyway. So I'll take the risk of saying that everyone tuning in today has at least one mutual goal. We all want this number here to increase. 5.2 billion cellular IoT connections are expected by 2025, according to Ericsson's latest mobility report. We all want to see more use cases for cellular communication in IoT and more users or organizations adopting cellular as their connectivity of choice. Actually, one of the impacts of COVID-19 that we're seeing is that organizations are relying more on using remote communication with connected devices. So we see a future to that. But there are inhibitors holding the public back from using cellular. For example, in 5G adoption, 32% of businesses state security as a barrier to 5G adoption, according to an Accenture business survey. And in an AT&T study last year, 72.5% of the respondents rated their level of concern as high or medium high when it comes to the potential impact of 5G on security. According to 5G America's organization, privacy concerns are one of the main inhibitors to adoption. The inherent vulnerabilities of the cellular network are holding back companies from adopting 5G for their most sensitive cases, such as critical infrastructure, smart cities, and connected vehicles. Now, sometimes the dangers of mobile networks are based on fiction. And here's a screenshot straight from my Facebook search from this week. But when it comes to cybersecurity, there is indeed a lot to be wary of. One of our mutual goals is to understand where the real risks lie and to be ready to support our customers to enable their business growth securely. But what are the risks? So because IoT is a relatively new and versatile domain, dealing with security is a dual challenge of understanding the possible attack vectors for every specific device and deciding what security measures are needed to mitigate them. So the following is by no means a complete list of attacks, as new ones continue to be discovered in the wild. It does, however, provide a thorough overview of some of the biggest and most common threats to cellular IoT devices in 6 groups. Let's start with identity compromise. In torpedo attacks, hackers send multiple SMS or service requests to a device in a short while. They then sniff the paging message to determine the temporary mobile subscriber identity, TMSI, of a device, and subsequently learn the location and even the IMSI of the device. This in turn can reveal the device owner's identity. IMP 4GT attacks allows cybercriminals to impersonate devices or users by exploiting integrity protection flaws in the cellular connectivity protocol. Though somewhat complex to deploy and implement, this type of attack can modify the IP identity of the target device, called an uplink impersonation, or the IP identity of the network server, called a downlink impersonation. Then the attacker can access any service on the network while assuming the victim's identity. Alternatively, they may mimic a legitimate service provider's communications that the target device may connect to. Perhaps the attacker wants to access corporate networks to steal information or to gain information about smart meter devices to later modify their readings. Device manipulation. Battery drain attacks can end up being costly when batteries need to be replaced in remote locations and service may be interrupted. One method involves waking up a component within the system far more frequently than is necessary, which drains the battery of the device. If we think about weather or pollution sensors, for example, these can be spread out over an entire country, resulting in hundreds of works to replace batteries and a long recovery time. Another option is attacking functionality, performed by exploiting loopholes in the device or network systems to gain access to control functions. Those can be unintentional, but can also be inserted deliberately by saboteurs during the manufacturing process. Such exploits can be used to impact service operation, spread botnets, or implement denial of service attacks, which overwhelm an IoT device and its network. Data channel rerouting is used to capture sensitive information and tamper with commands sent to IoT devices and services on the network. Attackers can modify the path of data to and from the attack device in the cellular network. Once in control of this path, attackers can use it to sniff outgoing data and tamper with incoming commands. In most cases, the attack involves maliciously altering the APN registered on the device or the intervention in DNS, domain name server resolution, to control what IP address is resolved for the APN. This could include routing information from surveillance cameras as a preliminary action before a physical attack on a sensitive location. IoT devices themselves can be used as a way to gain access to the internal systems of a company, actually being a gateway. Hackers exploit vulnerabilities within the device and use that device to get into the other zones in the network of the company. This lets attackers effectively steal data, trade secrets, and other critical information. In addition to using IoT devices to gain access to data, attackers can employ them to launch distributed denial of service, DDoS attacks, to shut down some or all aspects of operations. Attackers typically exploit devices that are poorly protected, leaving security holes in the perimeter, such as factory default passwords. The most infamous botnet being Mirai in 2016, that impacted 6 million devices at its peak. Though the Mirai designers have been caught, their source code lives on and has subsequently been altered and reused by other cyber criminals. Denial of service attacks are designed to cut off devices from the network. These attacks can disconnect manufacturing and monitoring systems, halt the production of electricity, all while preventing administrators from accessing their systems. Targeted denial of service attacks single out a specific connected device or a group of such devices. Non-targeted denial of service attacks aim to knock down everything on a network rather than disrupt the service of a specific device, often executed by attackers aiming to disrupt an organization or even a whole nation, impacting devices and services indiscriminately. Service denial of service attacks, similar to other DOS attacks, but with the intent of disabling business or national services and not specific devices. For example, such an attack can disable the logging service of an IoT device while leaving functionality intact to be used in the next stage of a multi-layered attack. Let's take connected vehicles, for example. A targeted attack could be denying service to a VIP's car so they could not navigate or update security patches. A non-targeted attack could be denying service to any car near a certain intersection, causing a massive traffic jam. And a service denial of service attack could be denying service through the network to a fleet of delivery trucks, causing chaos for the logistic company. In cellular networks, such attacks are often launched by flooding the device with information that triggers a crash, or exploiting flaws in the cellular network's connectivity protocols. These flaws enable attackers to impersonate the identity of another, legitimate device connected to the service, as with IMP4GT attacks, for example, which in turn lets them flood the network to deny service to other endpoints, or deny service to certain devices with fake cell towers and SS7 flaws. By exploiting existing flaws in communication protocols like SS7, attackers can gain access to the location of the device. While not very significant in static cellular IoT deployment scenarios, such attacks can put at risk valuable assets transported in connected vehicles. Unlike location tracking, which follows a device around, location checking lets attackers know when a compromised device enters a certain geographic location. This can be, for example, a trigger as part of a wider attack to harm devices or business operations in a specific area, like checking which types and how many devices there are around a critical infrastructure building or a factory to find a virtual or physical point of entry. So with all these maybe somewhat confusing threats being based on the mobile network, is there really an opportunity for mobile networks or operators themselves to save the day? The same Accenture survey we showed earlier revealed that although 40% of executives plan to partner with telcos on their 5G journey, 60% of executives say that telcos lack knowledge about 5G challenges in their industries. Increasing trust in 5G networks and in telcos' ability to deal with the challenges of 5G may increase enterprise adoption and speed up monetization on the investment in 5G. We can infer that the same is relevant for IoT deployments, which are characterized by similar uncertainties. So, if mobile operators can provide solutions, organizations may be keen to work together with them. But how? Well, you can start off by being a go-to source for knowledge on security. Teach and support using best practices. Help organizations understand what they're up against and support them in finding solutions to improve their security posture. I recommend checking out T-Mobile US's IoT for Business website. They've done some nice work on this topic. But what if your team doesn't have the know-how? If I may refer to the previous session by Mr. Laznica, Orange's IoT CTIO session, a strategy of collaboration and partnerships can drive IoT to maturity in security as well as in operations. At FirstPoint, we believe that the mobile network not only encompasses risks, but is also a core component in mitigation of cyber risks. By understanding the complexities and limitations of mobile networks, we've been able to build a solution based on the network that tackles the entire cyber threat landscape. FirstPoint provides a cellular cybersecurity service. We partner with mobile network operators, IoT service providers, private networks, and EPC providers to create a secured network through which protected device traffic, signaling, and data traffic is routed, while unprotected device traffic continues to be routed through the operator's original network. Mobile communication is analyzed, applying predefined security rules and organization-controlled policies. Malicious network activity is detected, alerted, and blocked by the system. End users and CISOs receiving real-time alerts. Our SIM applet enhances on-device security and device network anonymity. By adhering to a mobile network-based approach, we can give users and organizations the same advantages that made them choose cellular connectivity for their IoT deployments in the first place. Scalable, as easy as scaling connectivity, and even easier. Widespread, as far as the network can reach. Agnostic, for any device with mobile connectivity. hassle-free, with no impact on operations or battery, being invisible. Evolving, designed for 2G to 5G and ready for the future. And critical, dealing with the most sensitive use cases. Centralized, easy to update and roll out changes, and managed in one central platform for all connected devices. For MNOs, MVNOs, MVNEs, and IoT service providers, there is an opportunity to be the secured network in branding and, more importantly, in practice, thus gaining trust from customers and providing much needed security from potential threat actors while meeting any sensitive customer use case at all times. And I'll leave you with one last thought before the Q&A. IoT deployments for organizations are hard and laced with uncertainty. Many mobile operators already have a relationship of trust with their customers, which can be an opportunity for being the solution to customer cyber concerns. Thank you for your time, and now we'll open the floor to your questions. With me, we have Adam Weinberg, co-founder and CTO of FirstPoint.
Okay, so thank you very much, Noah. Not being a security expert, my overwhelming response to presentations like that is fear. I'm glad there's somebody to fix it. So we have John Jones who's asking, in the instance of cellular jamming 2 to 5G, does the point first solution offer protection?
And you're talking about cellular jamming?
Yeah,
so
between from 2G to 5G, yes. And can you guard against that? Can FirstPoint guard against that?
Yeah.
Yes, so I'm going to pass along to Adam, right next to me.
How do you do? Welcome.
Hi, thank you everybody. Hello everybody. Yeah, it depends on the type of the jamming. To be concrete, if the jammer tries to jam some of the frequencies or part of the frequencies which he thinks that the relevant device is using currently, we in some occasions, including a solution, the capability of changing the mobile identity of the user, so you may use another provider with another frequency, so by this avoiding the jamming. So it's a way of cat and mouse, but this is certainly part of the solution that we provide.
Okay, thank you. We have another question now from Igor Jurczyk. And he says, security is a crucial issue for IoT success, but also the implementation of IPv6 is crucial too. Will it be possible to solve the problem of security, such as for smart homes and smart factories, of which we're going to hear more later, with the implementation of IPv6 across the entire internet? So for example, if IP addresses are delivered to some members of smart homes and only they can manage the devices, will it solve the security issue, or at least will it be one of the key factors? So we're looking at how important is the proliferation of IPv6 across the internet to security in IoT.
Well, IPv6 may address some of the risks and threats currently available, over the internet. Certainly, threats which are related to the limited IP address space in IPv4. But other than this, I think that eventually, we still don't see it, but we believe that eventually most of the risk will be available also in IPv6, because they are related more to the content which is delivered over the internet connectivity and not to the actual lower layers of the connectivity itself. So all the risks.
Sorry.
So yeah, this is what I was saying. So actually, most of the risks are coming from the application layer and from the content layer, and not from the connectivity layer.
So the underpinning protocol is not, from your point of view, the really critical issue in security. It's what is carried, the traffic that they carry.
Yeah, but, you know, when we are talking about security, everything is important, but despite of this, there are always, you know, possibilities for the attackers, which are always very active to explore and to penetrate. And and most of those loopholes and tech patterns that are discovered eventually are related to the content and to the applications that are running above the connectivity.
I don't know if you can answer this question, and maybe it's unfair, but Noah, you cited that Accenture research and the way in which telcos are looked at regarding security seems to me to be bizarre when you consider that, if you know anything about it, the amount of security that's involved in a telco operation. Have you got any thoughts about how the perception of telcos and security could be changed? And for example, what your role might be in that?
Sure. So I will address the Accenture survey. I think I'll say as a consumer, okay, as a person, mostly consumers are not aware of the amount of security that telcos implement in the background. And perhaps businesses and more tech savvy and telco savvy businesses understand the amount of security that goes into telcos. So that's just, you know, one point in addressing that. And the second part of your question, I'm sorry, Annie?
I was just wondering, could you play a part in that role of helping to change perception? But I'm also wondering, you know, if it's consumers who don't really get what's going on in the background, whether that's not such a big issue as long as enterprise customers understand. I don't know what you think about that.
Yeah, so I think firstly, I do want to connect to the previous session about collaboration, and that's true in business and in cybersecurity. I think moreover, I mean, cybersecurity really is a global effort, and every company takes part in their specific expertise. And I think that's the same for telecom security, cybersecurity, and security in general. And I think, I mean, I hope we have a very significant part to play in the world's tackling of cybersecurity concerns in cellular. And, you know, that's why we're here, and that's why we get up every day and go to work to do some good in that sense. And I think there is a place to collaborate, and maybe B2C kind of customers don't understand what telcos do, but B2B customers do understand it. And I don't think anyone holds telcos responsible for SS7 or diameter standards that have flaws, and would be very glad to get some other solutions that really enhance security even more than telcos can do today. I hope that addressed the question.
That was quite comprehensive. Thank you very much. I'd like to thank both of you also for your sponsorship of this event, but for a really interesting session and some very helpful answers. Thank you very much indeed.
Thank you.